Tween, short for in-betweening, is an application of the Lerp formula, which can be used to adjust properties over time without the restriction of linearity. With two known data points, we can apply the Lerp formula to interpolate as many data points as we need in between them, adjusting a property over time. Let's take a look at the Lerp formula. How tweening differs from lerping is that tweening doesn't have to be linear, meaning we can apply a function to the value of t to change its value. This is called a transition formula. Let's take a look at the simplest example, the quadratic transition, where we simply multiply t by itself. Since 0 times 0 is 0 and 1 times 1 is 1, the known data points are still the same. But all of the data points in between will shift slightly, being closer together at the start and further apart at the end. If we apply this to a game object's position, it will move slower at the start and faster at the end. Similar transition functions exist for cubic, quart, and quint, simply multiplying t by itself one more time to make the transition sharper each time. More complex formulas can also be used which move backwards, like bounce, and some even extend outside the limits of the known data points, like back or elastic. Here's a graphic that shows all of the most common transition formulas as a graph with time on the x-axis and the property being tweened on the y-axis. All of these examples have been easing into the transition, meaning they typically move slower at the start and faster at the end. But we can switch them around to ease out instead, moving faster at the start and slower at the end. They can ease both in and out, moving slower at both ends and faster in the middle, or ease out and in, moving faster at both ends and slower in the middle. This gives us lots of more interesting ways to adjust properties over time.